In this lesson, we're going to talk about the areas of sectors inside of a circle. So in the previous lessons, we've talked about how to find the area of the whole circle. Now we're going to talk about how to find the area of pieces of a circle or different parts of the circle. So before we get started on the new notes, go ahead and complete the warm-up. And after you're done, unpause the video to see the answer. So it says estimate the area of the shaded region, also known as the sector. Describe how you would find the area of the shaded region. So we learned previously that the area of a circle was area equals pi r squared. And then if we wanted to find the area of, if we used that to find the area of this whole circle, we would then need to figure out what the area is of just this piece right here. So if we do that, we have, if we found the area of the circle, we'd have pi times 4 squared. That gives us 16 pi centimeters. Now, to me, that looks like this is about a quarter of a circle. I also know that there is 90 degrees in this angle right here, this central angle, and I know that if I do 90 times 4, I get 360 degrees. So if I wanted to find the area of shaded region, so area shaded, I would take 16 pi and I would divide that by 4, and that would give me 4 pi centimeters, 4 pi squared centimeters. Let me rewrite that, I wrote that wrong, 4 pi centimeters squared. Okay, so the area of the shaded region we're estimating is 4 pi centimeters squared. So again, previously we've talked about how to find the area of a circle using pi r squared. What we're going to look at here is how to find the area of 3 different pieces of a circle. So the 3 pieces that we have are called a sector, a segment, and an annulus. So a sector, think of it just as a piece of pizza where you cut a slice off, okay? It is the region between 2 radii and an arc of the circle. So again, you have down here, you have this shaded region would be considered a sector. A segment of pizza would be if you had a circular pizza and you made a straight cut across the pizza and you had sort of this little semicircle looking thing. And then an annulus would be if you took a circular object and cut a hole in the middle of the pizza and removed it. The annulus is all of this area that is left. Think of it, it's almost like a donut. Okay, so if you look at a donut with a hole in the middle, assume it was a full donut with no hole. You cut the hole out to make the donut, and then whatever you're left with, that is your annulus. So to find the areas of these 3 different figures, it kind of helps us to look at what the book refers to as picture equations. Okay, so essentially what we're doing is we have a picture here, and we're using this picture to help us figure out what the equation is to find the area of a sector. So if we take a look at this, it says if you find the area of the circle, which is pi r squared, and then if you take the central angle, the angle that is at the center of the circle that creates this sector, if you take that and divide it by 360, that gives you the percent of the circle you have. And so if you take the central angle times 360, multiply that by the actual area of the circle, that's going to give you your area of a sector. So this right here is area of a sector. To find the area of a segment, if you look at this picture, you'll see that you have this segment right here that we want to find the area of. And if you look at this, it's actually equal to it's kind of like you have a sector of this circle, but you have to subtract the area of this triangle. Now we've learned previously that the area of a triangle is 1/2 base times height. So as you can see, what they're saying is find the area of this sector and then subtract the area of that triangle that's right here, and that will give you the area of the segment. And you can see that the height of the triangle is the distance from the center of the circle to the edge of the sector, or of the edge of the segment, and the base is the length of that segment right there. And finally, you have the area of an annulus. So if you look at this, what it is saying is you have two radii to consider. You have the radii of the big circle, and then you have the radii of the small circle. And what it's saying is if you take the large circle and find the area of this whole circle right here, so you find the area of that whole circle, and then if you subtract out this area right here, that would give you your remaining area. So it says find the area of the big circle, subtract the area of the little circle, that gives you the area of your annulus. Okay, so again, area of a sector, make sure you have that in your toolbox. You want to remember that. To find the area of the segment, you just subtract the area of that triangle from the area of the sector that exists, so area of segment. And then to find the area of the annulus, essentially what you're doing is you're finding the area of two circles and you're subtracting the small circle from the big circle. So that's the area of the annulus. And again, those are going to be important that you remember those. Okay, so let's do a few examples. It says find the area of the shaded sector. So we know the area of a shaded sector is equal to the central angle divided by 360 times the area of the circle. So if we do that, we have the central angle is 45 degrees. We divide that by 360. We multiply this by pi and times 20 squared. So typing that into our calculator, we would have 45 over 360 times pi. Again, you want to type in the actual pi, don't put in 3.14. So you would get 157 point, round it to 0.8, and that would be centimeters squared. Now, another way that you could write this, and this is actually the way that I would recommend writing this, is you could just you don't have to type in pi. You could go 45, so if you were to do that, what I mean by that is you would type in 45 divided by 360, and then you would multiply it by 20 squared, which gives you 50. So another way to write this answer would be 50 pi square centimeters. So again, what you do there is instead of multiplying by pi, that will give you a decimal answer that you have to round, you multiply just the 45 over 360 and the 20 squared, and then at the end you put times pi. So it's 50 times pi centimeters squared. Now, if we want to find the area of the shaded segment in example B, again, we know that the area of a shaded segment is the area of this sector right here minus the area of this triangle. Okay, so if we look at that, we have the area of that sector would be, it's a 90-degree central angle, so the area is equal to 90 over 360 times pi times 6 squared minus the area of that triangle. The area of that triangle is going to be equal to 1/2 times the base of that triangle, which is 6, times the height of that triangle, which is also 6, because here's the height, here's the base, they are both radii. So we go ahead and we type this in. 90 90 over 360 times 6 squared, which is 36. So this will be equal to 9 pi. Then 36 times half is 18, so minus 18. So we could leave this as our answer, 9 pi minus 18 square centimeters. Or you could type in 9 pi minus 18, which would give you 10.27 square centimeters. So again, there you're actually getting a number without the pi, but you do have to round it, and it's not an exact answer. If we take a look at example C, it says find the shaded area is 14 pi centimeters squared. So it's saying that this area is 14 pi centimeters squared, and it says the radius is 6 centimeters. It wants us to find x, the central angle. So we'll do this work over here. So we know that the area is equal to 14 pi. We know the area of a sector is equal to a over 360 times pi times the radius squared. So what I'm going to do here is I'm going to multiply everything by 360. So 360, and all I have to do here is 360 times 14 is 5,040. So we have 5,040 pi. That's equal to that's equal to a times 36 pi. If we divide by 36 pi, the pi's canceled out. 5,040 divided by 36 is equal to 140. So we get A, the central angle, is equal to 140 degrees. Now, if we take a look at these other two examples that we have down here, it says what is the area of the part of the annulus shown here? Okay, so this problem's slightly trickier. We know that the whole piece would look like this. So what we can do is we could figure out, let's find the area of this whole annulus. So the area of an annulus would be the area of the big circle. So area is equal to pi times r squared, so 5 squared, minus the area of the small circle, pi times 3 squared, which would be equal to 25 pi minus 9 pi, which would be equal to 16 pi. All right, so that is the area of like this whole piece. Now, if we want to find the area of just this shaded region, okay, well, that's a piece of this annulus. So to find out that piece, what we would want to do is we'd take 360 minus 120. That tells us that this is 240 degrees. So that central angle is 240 degrees. So we want to take this, we want to find the area shaded. We can say we have 240 over 360 times 16 pi. So 240 over 360 times 16, that gives us, we change that, so we can write that answer as two ways. We can get 32 pi over 3 centimeters squared, or you could write it as 10.6 repeating times pi centimeters squared. Okay, so again, what we did there is we found the area of the whole annulus that we would have had, and then we multiplied it by the amount that we wanted to know, which is 240 over 360. The final example says Shayna has a circular flower garden with a radius of 10 feet. She has roses planted in a sector of the circle with a central angle of 60 degrees. She wants to increase the area of the sector with roses. Which will give her more area, doubling the radius or doubling the central angle? So the area of this sector, Again, the area of a sector is A over 360 times pi r squared. So the question is, should we double the radius or should we double the central angle? It tells us the central angle is 60, so if we doubled that, you'd have 120 over 360 times pi times 100, because r squared, 10 squared is 100. So that would give us 120 times 100 divided by 360. That gives us 33.3 repeating pi square feet. Okay, so if we double the central angle, that is our new area. And then if we double the radius, we'd have the same 60 degrees over 360 times pi over 20 squared. And that would give us 60 times 400. If we divide that by 360, we get 66.6 repeating pi feet squared. So as you can see, the area by doubling the radius, so which will give her more area, doubling the radius. So that is how to find the area of different sectors, segments, and annuluses of a circle. So go ahead and begin working on the homework. If you have any questions, please message me on Remind or email me, and feel free to ask questions at the beginning.